We are working through the problems on the Chapter P review sheet, and now we come to some radical expressions where the directions say to simplify each expression as much as possible. So first thing we're going to simplify is the square root of 490 times a to the 16th power times b to the 5th power. And so what we want to be doing here is pulling as much as we can out from under the radical sign. 490 is not a perfect square, but we can factor it into something that is a perfect square times something else. Specifically, it would be 49 times 10. A to the 16th, now that is a perfect square. It's what you get if you start with a to the 8th and square that. So we are going to be able to say what the square root of a to the 16th is. It's just going to be a to the 8th. And then b to the 5th power is not a perfect square, but we can break that up into b to the 4th times b, or b squared times b squared times b. b times b times b times b times b. And now if we go ahead and take the square roots of the things that we can take square roots of, square root of 49 is 7, square root of a to the 16th is a to the 8th, square root of b to the 4th is b squared, and then we still have under the radical sign the 10 and the b. So it's this times the square root of 10b. Now let's simplify 10 over the square root of 2. Here we're going to rationalize the denominator by multiplying by another square root of 2 on top and on the bottom. So really we're just multiplying by square root of 2 over itself, which is 1. We're not changing the value of this expression, just trying to get it in a different form. So when we do this, on top we have 10 times the square root of 2. On the bottom we have the square root of 2 times itself, the square root of 2 squared, which is 2. And we have rationalized the denominator, but now we can take 10 over 2. 10 divided by 2 is 5, so our final answer is 5 times the square root of 2. How about this? 24 over the square root of 7 minus 1. The trick to rationalizing a denominator like this, that has more than one term, is to multiply by the conjugate, the thing that has the opposite sign in the middle. So in this case, that would be the square root of 7 plus 1. So when we multiply by the square root of 7 plus 1 on top and on the bottom, on top we get 24 times the quantity square root of 7 plus 1. And on the bottom, it's like we multiply it out, we get a difference of 2 squares. We get the square root of 7 times itself, the outside and the inside cancel, minus 1 times itself. So continuing to multiply things out, 24 times the square root of 7 plus 24 times 1. Oops, that was supposed to be a plus. And then down here, this 7 minus 1 would just be 6. And both terms on top can be divided by 6. So this reduces to 4 times the square root of 7 plus 4. The cube root of 64x to the 12th is, well, we can take cube roots of both of these things. 64 is a perfect cube. It's 4 cubed, so the cube root would be 4. And then x to the 12th would be x to the 4th cubed. It would be x times x times x times x times another one of those times another one of those. 3x, x, x, x is all multiplied together. So the cube root of the whole thing is 4x to the 4th. Now we are supposed to plot the points 3, 2 and negative 5, 8. So 3, 2 is over 3 and up 2. It's right here. And negative 5, 8 is over negative 5 in the x direction and up 8. So that would be right there. Next, we're supposed to find the distance between those 2 points. How far apart are they just in a straight line? Using the distance formula, we take the square root of x coordinate minus x coordinate squared plus y coordinate minus y coordinate squared. So negative 5 minus 3 is negative 8, and 8 minus 2 is 6. And both of those numbers get squared. Negative 8 squared is positive 64, because remember, a negative times itself comes out positive, and 6 squared is 36. Next, we add those together to get 100, and then the square root of 100 is 10. And now, find the midpoint of the line segment connecting these points. So that would be the point halfway between them. So it is going to be a point. We need an x-coordinate and a y-coordinate of that point. The x-coordinate of the midpoint is going to be halfway between 3 and negative 5. And the y-coordinate is going to be halfway between 2 and 8. So we can find what's halfway between two numbers by sort of averaging them together, adding them together and dividing by 2. So 3 plus negative 5 divided by 2 is negative 2 divided by 2, which is negative 1. And 2 plus 8 divided by 2 is 10 divided by 2, which is 5. So the midpoint is at negative 1, 5. And now for a special fun bonus problem. This takes a little longer and gets a little more complicated than the others. If I did put this on the test, it would be a bonus problem, the kind of thing that you didn't have to do but might get bonus points for. But if I'm trying to keep the test short, I wouldn't put something like this on it. But it's really just a matter of putting together things that we've already done in others of these review problems. So let's look at what all we've got going on here. We've got one rational expression, one fractional expression here, times another one, minus another fraction, divided by another fraction. And remember the order of operations. Multiplications and divisions come before additions and subtractions. So we would have to do the multiplication here and the division here before we worry about the subtraction. And when we're doing a division, remember how we do that? We change that into the multiplication of the reciprocal. So, leaving the subtraction for later, we've got ourselves two multiplication problems. 2a squared over a squared minus 25 times a plus 5 over a minus 10b squared minus 30b over b squared plus b minus 12 times b plus 4 over ab minus 5b. For multiplication, we want to factor everything we possibly can so that we can see if there are any common factors that we can get out of the way. Do you see anything that factors here? You should, whenever you see a difference of two squares, one thing minus another where they're both perfect squares, be thinking, aha, difference of two squares. Factoring formula, first thing plus the second thing times first thing minus the second thing. So that factors into a plus 5 times a minus 5. That's the only thing that factors here, although remember a squared does mean a times a. And then over here, we can pull out the greatest common factor of these two terms, which is 10b. So it would be 10b times b minus 3. The b squared plus b minus 12 can be factored. And for ab minus 5b, there's a common factor we can pull out there. So here's what everything looks like once we've done all the factoring we can. Inside this first set of parentheses, what do you see that we can cancel? There are factors at a plus 5 on top and on the bottom. And there's one other thing I can cancel. The a on the bottom here can cancel with one of the two factors of a up here. So a squared over a leaves me with just one a on top. And over in this set of parentheses, do you see what I can cancel? I've got a b minus 3 over another b minus 3. And I've got a b plus 4 over a b plus 4. And there's a factor of just b on top and on the bottom. So what's left after all that canceling? Well, here we have 2a over a minus 5. Minus, here we have 10 over a minus 5. Now it boils down to a subtraction problem. 2a over a minus 5 minus 10 over a minus 5. And one thing that makes me really happy is that these have the same denominator. Subtracting is a lot easier when you're dealing with things that already have the same denominator. We can just keep that common denominator for our answer, and the numerator becomes 2a minus 10. Are we done, or is there something else we can do with this? Well, on top, we can pull out a common factor of 2 times a minus 5 over the a minus 5 on the bottom. Those a minus 5s do divide out and leave us with just 2. So that big complicated expression that we started with, it's equivalent to just 2.